Number 17 on the geometry final review worksheet is a secant tangent, and the secant tangent formula is it is the whole thing times the outside part is equal to the length of the tangent squared. So it's the tangent squared. That's the formula. And this whole piece right here is 16. So 16 times the outside part is equal to this piece right here, which is what we're trying to find. So we'll call that x squared. So 16 times 4 is 64. And we take the square root of both sides, and we find out that x is 8. So find AB. AB is 8. Okay, let's see. Is this even the one we're supposed to be working? Yeah. So we'll check number 17 real quick. 15. 17 is 8. Okay, back to this one. Find the area of the shaded region. Well, this is what we call a segment in a circle. The segment is this shaded pink thing. It is, we find that by finding the area of the sector, those that I have the pink lines in, that whole piece. We find the area of the sector, and then we subtract out the area of the triangle. So this is the formula for finding the area of a sector. I got that off the circle that we made. Has all the circle notes on it. So they gave us this arc measure, and we know it's a measure because it's 120 degrees. So the arc measure, so that's the measure of the central angle as well. So 120 over 360 is equal to the sector area over the area of the circle, and the area of the circle is pi r squared, so that ends up being 36 pi. I'm going to make this easier and take out those zeros, so reduce it. So 12 over 36 and 12 over 36 reduces down to 1 over 3, and that's equal to the sector area, that's what we're looking for, divided by 36 pi. So you cross multiply and you get 36 pi is equal to 3 times the sector area, so divide both sides by 3, and you get 12 pi. So the sector area is equal to 12 pi. So all of this is 12 pi. And now we got to find the area of the triangle. There's a couple of ways to find the area of the triangle. You can do 1/2 AB sine C, since we have 60, 60, and the sine of 120. This is going to give us a decimal answer. We've seen all of the answers in previous problems have been exact value, so it might be better to do the 1/2 base time height. So I'm going to redraw the triangle that we have down here. I'm going to draw that perpendicular right there, because we know we can always draw a radius, and when we draw that radius it'll be 6. We can draw it perpendicular. This piece is 6, this piece is 6. We'll draw it perpendicular so that these two pieces are the same size. We also, when we draw that piece, we cut that angle into 2 equal parts. So this part will be 60, this part will be 60, and that means that these two angles must be 30. So we have a 60-30 triangle now, and we know the hypotenuse. The hypotenuse is 2x. The side across from the 30 is x. And this side right here is x square roots of 3. So I know 2x is equal to 6, because that's the side length that I know, and it's the hypotenuse. So that means x is equal to 3. So this little piece right here, which could be considered the height of the triangle, that piece is 3. And then the base, okay, which is that piece right there, is going to be, each piece is going to be 3 square roots of 3. So the whole thing, I got 3 square roots of 3 right there, 3 square roots of 3 right there. So this is going to be 6 square roots of 3 right there. So to use this formula right here, the area is 1/2 the base, which we said is 6 square roots of 3, times the height, which we said was 3. So that equals 9 square roots of 3. So the area of the shaded section is 12 pi minus 9 square roots of 3. Now, that's an exact value. You can type it into a calculator and get a decimal value. I'm going to check my answer real quick. 12 pi minus 9 square roots of 3. All right, number 21. The area of an equilateral triangle is given 25 square roots of 3. Find the length of its sides and its altitudes. So I drew an equilateral triangle, and I drew in its altitude. And based on the fact that all the angles of an equilateral triangle are 60, then this one's 60, this one's 60, this one up here is 60. When I draw the altitude, it cuts it into a 30-degree angle. The side opposite the 30-degree angle is the one we call x. That means that the hypotenuse is 2x, and the altitude, or the height of the triangle, is x square roots of 3. Now, they've given me the area. Area, we know, is 1/2 base times height. That's one formula that we could use. We could also use area equals 1/2 AP if you'd want to work it a different way, because we have the area and we could write the apothem and the perimeter in terms of each other. But it doesn't matter how you do it. As long as you only have one variable, you'll be able to solve it. So based on our 30, 60, 90 formula right here, we know that the base of this triangle is going to be 2x. Because if this hypotenuse is 2x, then all the legs of the equilateral triangle are 2x. And then the height is going to be x square roots of 3. So we have an algebra equation now, and we only have one variable. So all we have to do now is solve for x. So the 1/2 and the 2 cancel each other out. And so we get x squared times the square root of 3 is equal to 25 square roots of 3. To get the x by itself, divide both sides by the square root of 3, and they cancel out on both sides, or divide out. Cancel is not a good word. And then to figure out the value of x, we take the square root of both sides, and we get 5. So find the length of its sides. So the length of the sides are 10, and the altitude, and any other altitude, we can draw the other altitudes as well. They'll all have the same length. They are going to be 5 square roots of 3. Okay, that's number 21. We can run and check it real quick. What happened? Did I skip number 19? Must have. What happened to number 19? There it is. I went out of order. That's okay. We'll come back and get 19. We just did number 21. 21, side length 10, altitude 5 square roots of 3. All right, so let's do number 19. It says a square pyramid with a base edge of 4 is inscribed in a cone with a height of 6. And they gave us the picture of the cone, so I just drew my square pyramid inside. Find the volume of the pyramid and the cone. So the volume formula for the cone is, well, it's the volume formula for both of them. The volume for the cone is 1/3 the area of the base times the height. Each one of them are going to have a height of 6, so we know the height and the volume for the pyramid is equal 1/3 area of the base times the height. Well, we know the height is 6. This is 1/3. And so for the pyramid, the area of the base, that's what that B stands for, is pretty easy. It's just 4 times 4 because it's a square. So 4 times 4 is 16. Oh, I forgot to put a 6 in right there. The height is 6. So multiply 16 times 6 and divide it by 3. And I think you get 32. You do. So the volume of the pyramid is 32 units squared. Doesn't give me any units on this one. Okay, now for the cone, the area of the base, since the base is a circle, we need pi r squared. Well, we need the radius, and the radius is going to be from the center of the circle to the edge of the circle. So I drew it down here so that you could see better the circle with the square in it. And the square, those each have a side length 4, side length 4. So this is a 45-45 triangle. So if these two legs are 4, then the hypotenuse is 4 square roots of 2. Well, the hypotenuse is the diagonal. So the diagonal is 4 square roots of 2, so the radius is half of that. So the radius is 2 square roots of 2, so it is the radius, which is 2 square roots of 2 squared, and then we got to multiply it times pi. Okay, so 1/3 times 2 square roots of 2 squared, so we've got 1/3, that's 4 times 2 times 6 times pi, and that is 8. I think that's going to be 16 pi. I did that mental math, so it's the volume of the cone. The volume of the cone is 16 pi. The volume of the pyramid is 32. That was number 19. 32, 16 pi. So I did that one right. And now we're going to go find the volume of a sphere inscribed in a cube if each side of the cube is 6. So if the side of the cube is 6, then that means that the sphere all the way across the sphere is also 6, which means that the radius is 3. And the volume for a sphere is it 4/3 pi r cubed? I believe that's what it is. And so the radius is 3, so it's 4/3 times 27 pi. So I think that's 36 pi. And again, that's my mental math. Got to be checking it. 3 times 3 is 9. 9 times 3 is 27. And then 27 divided by 3 is 9. 9 times 4 is 36. Okay, I got that. Now, find the volume of a sphere. That's all it asked me to do, so it's 36 pi. Let's check. The answer, number 20, was 36 pi. All right, that's all the pictures that I have up. Yep, we did that one. I did it out of order. We did 17, 18, 19, 20, and 21. Okay, so the next video will start with number 22.